If you ask the average person about AI right now, you'll probably hear a heavy sigh. People are exhausted by free-tier chatbots that confidently hallucinate recipes and butcher basic search queries. It feels like the technology has completely stalled out. But that fatigue is built on a massive blind spot. Behind the scenes, paying professionals at major companies are experiencing a level of automation that the general public simply cannot see. Take a look at this chart mapping out the current AI landscape. On the bottom left, where model cost and human effort are low, we have the free tools driving that public perception, low-capability systems that require constant prompting and handholding. Now look up at the top right quadrant. This is the agentic reality. Enterprise tech leaders are quietly deploying heavyweights like GPT 5.6 Pro, Cursor automations, and Gemini Robotics 2 for complex workflows. We call these agentic AI. Instead of waiting for you to type a prompt, an agent maintains a goal over hours or days. It triggers chains of actions, checks its own work, and interacts with other software without you sitting there to supervise it. Calculating the true ROI of removing a human from a workflow now requires looking past the raw capability of the AI and accounting for the specific operational costs of autonomy. Let's start with the software layer. If you're a CTO selecting a foundation model to write and deploy code autonomously, you face a sharp dilemma. Do you pay a massive premium to guarantee the model won't break things? Or do you optimize for speed and protect your budget? We can measure this trade-off using recent independent benchmark data, testing OpenAI's GPT 5.6 family against Anthropic's Claude models on complex enterprise engineering tasks, like planning a zero-downtime database migration. This chart shows how those models performed. If you want a flawless 100% reliability score, OpenAI's flagship model, Sol, sits right at the top. But look at its position on the x-axis. Sol is incredibly expensive per run, and taking 3 whole minutes to return a result makes it far too slow for high-volume workflows. Compare that to Anthropic's Opus 4.8 over here on the left. It drops slightly to a 92.9% reliability score, but it completes the exact same work at a fraction of the cost and in just 23 seconds. But the biggest surprise in the benchmark is right here in the top left. OpenAI's cheapest tier, Luna, matched Sol's perfect reliability on these specific workflows, costing just 4 cents per successful result. When cheaper models like Sonic 5 do fail in these tests, it's usually due to a specific technical issue called output truncation. The agent doesn't write bad code, it simply runs out of its token budget halfway through writing a long migration plan. To use these highly efficient models safely, engineering teams have to build automated compile and retry safeguards directly into their pipelines. If a model truncates, the system catches the error and forces a rerun before the bad code deploys. Paying flagship enterprise rates often just buys you latency, not necessarily a better result. The smartest financial play is building an architecture that routes high-volume tasks to the most efficient model available. But generating code efficiently is only half the equation. When senior developers use always-on agentic coding tools to act as orchestrators rather than manual typists, their individual productivity spikes dramatically. Suddenly, a single engineer can generate hundreds of pull requests in a week. That sheer non-human volume of AI-generated code actively overwhelms existing enterprise infrastructure. Legacy CI/CD pipelines were designed for human-paced development. They simply cannot withstand the non-deterministic behavior and massive velocity of agent-generated code hitting the system all at once. Scaling this volume requires a shift in resources. Teams are diverting engineering cycles away from building new features and toward creating automated security gates and verification systems designed specifically to monitor the agents. This creates a severe secondary problem for human talent. Because agents are taking over foundational coding tasks, junior developers face massive AI drag. Without those repetitive tasks to help them learn the codebase, early career engineers become harder to train and harder to justify keeping on payroll. By automating the entry-level tasks that once built deep systems knowledge, companies are effectively removing the training ground for their future senior engineering leads. The complexity scales up exponentially when agentic AI crosses from digital software into the physical world, consolidating hardware control into a single, scalable intelligence layer. Take the latest humanoid models operating in enterprise warehouses. A platform like the Apptronic Apollo, powered by Gemini Robotics 2, boasts a 92% success rate for unscrewing a light bulb. But ask that exact same robot to sweep a floor with a dustpan, and the success rate plummets to 32%. This is asymmetric dexterity. Because physical tasks scale so unpredictably, warehouse operators cannot just deploy a fleet of robots and walk away. They still have to budget heavily for expensive human intervention and oversight on the floor. The stakes are even higher in healthcare. Following relaxed FDA guidelines, hospitals are actively rolling out autonomous clinical agents to manage 24/7 patient care and alleviate administrative bottlenecks. This creates an uncharted legal minefield. When an autonomous agent makes a cascading error across a patient's chart without a human prompt, the liability falls simultaneously on the clinician using the tool, the hospital that deployed it, and the software developer who built it. In physical logistics and medical care, a marketed 92% AI success rate is meaningless unless the business has already budgeted for the liability and oversight costs of the 8% failure rate. Treating Agentic AI as a standard infrastructure layer rather than a simple software purchase requires building out rigorous routing logic and specific legal guardrails. Decision-makers who deploy autonomous agents without proactively updating their governance frameworks and QA pipelines will watch their short-term efficiency wins get rapidly erased by massive technical and legal debt. To calculate your autonomy ROI, look at this flowchart mapping out current deployments. If you manage human-in-the-loop workflows, your best move is routing tasks to optimize for cost, using models like Anthropic Opus or OpenAI Luna. Because a human is already there to supervise the output, the massive speed and cost savings easily justify the rare necessity for a worker to click retry. For zero downtime or high-stakes engineering tasks, the logic flips. You follow the path to optimize for reliability, deploying models like GPT 5.6 Terra or Sol, provided you can absorb the steep API costs marked by the red warning. Finally, for leaders in physical operations and healthcare, you have to treat AI agents like heavy machinery or high-risk medical devices. The route ends at a total cost of autonomy scorecard, forcing you to factor API fees, human oversight, and legal liability together. Longevity in this environment belongs to the teams that prioritize system resilience, focusing on how their architecture handles the moments when an autonomous model eventually misses the mark.